Good morning, everybody. How are you all? Today we are going to talk about how to use Excel to do t-test for a population mean. So let me share my screen with you. A researcher claims that the average height of tall buildings in the US cities is less than 700 feet. A random sample of 10 tall buildings are selected and their heights are recorded. Assume the sample came from a normal population. At alpha equal to 0.025, can you support the claim? So let me make a few small spelling mistake correction. Researchers claims that and a random sample. Okay. So the first thing we will do is we will calculate the mean of this sample and the standard deviation of this sample. So equal to average equal to average is the formula for the mean, and we will highlight from A4 through A13 and hit enter. So the average height is, this is the sample mean. Okay. Then we will calculate the sample standard deviation. So equal to ST div dot S because we are dealing with a sample. And then again, highlight from A4 through A13 and hit enter. So this is the sample standard deviation. Then we will calculate or count the number of samples is equal to count, C-O-U-N-T. And we are counting from A4 through A13 and hit enter. And that's your sample size. Sample size. So now we will calculate the standard error. Standard error is the standard deviation of the sampling distribution, which is sample standard deviation divided by square root of the sample size is equal to sample standard deviation is in cell A15 divided by square root is SQRT. Okay, square root and my number count or sample size is in cell A10. Okay, so that's your standard error. Okay, now we will calculate the test statistic. What is the test statistic? Okay, now before we calculate the test statistic, let me write the null hypothesis. Null hypothesis is mu, population mean, equal to 700 feet. And the alternate is mu less than 700, right? Because a random sample, a researcher claims that the average height of tall building in the US cities is less than 700 feet. So alternate is mu less than 700. Okay, so we will calculate the test statistic. What is the test statistic? Here we compare the sample mean with the hypothesized population mean, which is 700. So 700 is the hypothesized population mean, or mu 0. Mu 0. So That's mu 0. Okay, that's the hypothesized population mean. So I'll compare the sample mean to the hypothesized population mean. That is, take the difference between the sample mean and the hypothesized population mean, and then divide the difference by the standard error of the sample means. That means how many standard deviations or standard error away from the population, hypothesized population mean is the sample mean located. So equal to sample mean, we are comparing the sample mean, which is in cell A14, okay, minus the hypothesized population mean, which is in cell A20. Then the whole thing will be divided by is like this in the Excel, divided by standard error, which is in cell A17. Okay, so, and then you hit enter. This is your test statistic, T. Okay. Now the test statistic is a characteristic of the sample that we have collected. This tells us that the sample mean of 606.5 is located 19.82 times standard error below the mean because it's negative. Now we will find the p-value of obtaining a test statistic as low as minus 19 or below it. Okay, so equal to, we are finding the probability from the negative infinity where the t-curve extends to the left up until minus 19.82. That is, what is the area to the left of minus 19.82 under the t-curve. So equal to t, then t distribution, and now it is looking for x value, which is A21. We want the area to the left of A21. Degrees of freedom is sample size minus 1, which is 10 minus 1, 9, comma, 9, then comma, 9 is your degrees of freedom, and we say true because we want the area to the left of minus 19.82, that is stretching from minus infinity on the left up until minus 19.82. What is the area to the left of minus 19.82 under the t curve? So we say true for the third argument inside the parenthesis, and then hit enter. So this is the p value, that is the cumulative area under the t curve to the left of minus 19.82. Okay, so our p value is such a small quantity, 4.9 times e minus 9, and our alpha value, alpha, so this is the alpha value, 0.05. What is alpha? Alpha is the maximum probability of rejecting H0 when it is true. So this is your alpha. And we compare the p to the alpha. P value is less than alpha. Okay, so decision reject H0. Conclusion, if we reject H0, then we state that at alpha equal to 0.05, there is enough evidence to support HA. Evidence to support HA. Support HA, which states mu is less than 700. Okay, So again, let me summarize what I did. First, I found out the sample mean, which is equal to average. The data is from A4 to A13. Then I found out the sample standard deviation, which is equal to standard deviation dot S. Dot S implies that it's a sample standard deviation. And again, A4 through A13. Then I found the count of the numbers of sample or sample size equal to count A4 through A13. Then I found out the standard error. What is the standard error? It is a sample standard deviation divided by square root of the sample size. So A15 divided by square root of A10. What is standard error? It is the standard deviation of the sampling distribution of X bar. So our null hypothesis is mu equal to 700 and the alternate is mu less than 700. So what is our hypothesized population mean? 700. Then we calculate the test statistic, which is a characteristic of the sample that we have collected. That is, from the sample mean, we subtract the hypothesized population mean and then divide by the standard error. Okay, and it works out to be a very large negative number or very small negative number. Since this is a left tail test, we want to find out the cumulative area under the t-curve from negative infinity to negative minus 19.82. This will give us our p-value, okay? P-value. So p-value, okay? So that's our p-value. And our p-value is very small. It's actually decimal followed by 8 zeros and then 4, okay, which is much smaller than the level of significance alpha. Level of significance is alpha, is maximum probability of rejecting 80 when it is true. Since p-value is less than alpha, our decision is to reject 80. If we reject 80, then our conclusion is at alpha, conclusion is at alpha equal to point, it is actually at alpha equal to 0.025. There is enough evidence to support the alternate because we have rejected the null hypothesis, mu less than 700. I will stop here today. If you have any question or comment, write me a note. And if you like this video, please give me a thumbs up. If you like this video, please share with your friends. I'm coming back next time with another way to solve the same problem. So watch out for me next time when we will solve the same problem using another method. Okay. And please check out my channel. I have solutions to all kinds of math problems. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I will see you next time with another interesting problem, interesting solution. Actually, I will attack the same problems, or I will solve the same problem in another method, using another method. Take care. Have a nice day. Thanks for watching. See you next time.